Hello everyone, we are moving on to three-dimensional objects for LT3, 4, and 5 this chapter. This is Mrs. Ogier
and Miss Perrier,
and let's get started. So just a quick reminder, all of these formulas are what you are given on your reference sheet. So you do not need to memorize them, but you do need to know what they say. So let's talk about capital B. Capital B means area of the base. I repeat, area of the base. What does it not mean? Base. It means area of the base. It's extremely important that you recognize that. Super duper important. So, for example, with all of these prisms, if we look at the first one, what type of prism is that, Ms. Perrier?
It is a triangular prism.
Okay, it's a triangular prism, and we know it's a triangular prism because, again, the base is a triangle. So notice underneath that, I put 1/2 base times height in for capital B, and then the other height. Those two heights get confusing, I know that, but you want to think of the other height as kind of like the depth of the three-dimensional object. So for all of these, it's just capital B is area of the base and then times the height of the three-dimensional object. For this hexagonal prism on the right, it'd be whatever the area of that hexagon is. We don't have a formula for it, times the height. So no matter what, it's area of the base times the height. And again, we're going to think of that height in the formula as depth, because otherwise you have two heights and it might get confusing. But that other height is the depth of the object. So we will work through all of those. Okay, so let's do an example.
So here's our first one. As you can see, it is with our general prism. So we have to find the area of the base times the height here. Again, capital B means area of the base. So as you can see that we have to find the area of the green rectangle that is there. So plugging that all in, we know that it's 11 times 2 times 7, and put that all into the calculator, and make sure that when you label it is yards cubed, not yards squared, because volume is cubed.
Next example, this is a triangular prism. The reason I know it's a triangular prism is because the triangle is the repeated shape. If you think of it as a loaf of bread, if you slice the bread, it's going to be equal triangle slices the whole time. So that's how you know it's a triangular prism. It's important to know what it's called because that helps you know what capital B should be, and it should be area of the base. Then if we microscope in on that triangle, notice that 3 and 4 are perpendicular to one another, so you have the base and height of that already. You don't need that slanted 5, which is shown on the other triangle on the other side of it. So we substitute our values in. The area of the triangular base is 1/2 4 times 3, and then the height or depth of the prism is 10, giving you 60 centimeters cubed.
The next one here, we have a pyramid. So again, on your reference table, you have that formula for you, so don't worry about that. But now you need to make sure that you find the area of the base, which is a square here, so all you have to do is 10 times 12, times 1/3, times the depth, which is 10 here. So again, there it is, all for you. Put that all into your calculator as you see it, and then you'll get 400 centimeters cubed.
Next one is a triangular pyramid. This formula throws people off because of all of the fractions. So again, just follow the basic formula. 1/3 area of the base times height. The area of the base is going to be the triangle area. 6 and 8 are the base and height of the triangle because, again, remember, base and height must be perpendicular to one another. So this looks like the following. 1/3 from the volume formula, 1/2 from the area of a triangle, base times height, and then times height or the depth of the object. So in green there is that area of the triangle, and then we substitute that in. If it's easier, calculate your area of your base separately and then substitute it into the formula if it's too many things happening at once.
Next one here, we have a cylinder, and again, the cylinder is an equation that we get on the reference table. So again, when you are looking at this, 14 is our diameter here. It is not our radius, so you have to cut that in half to be 7 squared times our height, or our depth, 6. So again, put that all into the calculator. And again, you need to make sure remember, if it says in terms of pi, you don't put pi into the calculator. If it says round to the nearest hundredth, you put pi in the calculator.
So that would be what it is with pi, and it again would depend on what it says. I think it said nearest hundredth in the direction, so there you go. All right, cone. So this is a cone. We have 1/3 pi r squared h. With a cone, be careful because they could give you the slant height. In this case, they did not. They gave you that straight up and down perpendicular height, which is the one that we want. Just a quick reminder, if you are taking diligent notes, you might want to write sometimes the slant height is given and you need Pythagorean theorem for that one. But in this case, we have everything we need, so we just substitute all of our values in, dividing 6 into 2 because it's the diameter, and solving through with our calculator.
Now for this one we have a sphere, and the sphere again is on our reference table, 4/3 pi r cubed. So again, we are going to just take what we know from the picture and put it straight into our formula, put it in the calculator, and then there's the answer with pi in it, and then when pi is put into the calculator.
Now, I cannot tell you how many times I see students put a 2 there. It's cubed. The formula says cubed. Don't write squared. People do it all the time. Don't do it, please. It says cubed on the formula you're given. Write down the formula you are given correctly. Okay, now this is not a shape that we can identify. It kind of looks like a silo with a top or a house of some sort. Okay, this is called a composite shape when you have two shapes that are put together. So you need to be able to identify that you have a cylinder plus a cone. That's what you have going on here. So you need to find both of those volumes by doing exactly what we just talked about. So 1/3 pi r squared h for your cone and pi r squared h for your cylinder. Calculate each of those separately and add them together. And it's that easy.
For the next one, we have a cylinder and then a square on top of the cylinder here.
Square or rectangle? I gotta look close. 2 and 3. Rectangular prism.
Okay. Okay, so for this one, we're going to use our cylinder formula for volume, and we're going to use our regular prism formula for that. So again, all you got to do is take what you see from the picture and plug it into those two formulas there, and do the exact same thing, and then make sure you add them to subtract them together in the end.
Because this one is like, if you think of like a, I don't know, a bolt of some sort, I guess, if there's a hole in it. And it's hard to show that visually sometimes, so if you're ever not sure, that is something that if it's our drawings, we would tell you that there's a hole, or no, it's stacking, something like that. All right, now we're going to work backwards. So this time we're given a sphere with the volume, and we want to know what its radius is. So instead of substituting in for the radius, we have the v part of this equation. So this is what we would do by substituting values into the formula. From here, it's just algebra. The 4/3 and the pi are being multiplied by the r cubed. So we would need to divide those over. So we divide by 4/3 on both sides, and just showing what that would look like in your calculator, you would hit 582.6, your division symbol, and then you would do control divide to get that fraction to show up to make sure that it types in exactly how you want it to. Always double check that it looks the way you intended. And then we would divide by pi on both sides, again showing you what that would look like on the calculator. That pi button, as a reminder, is next to the letter H. And then we have this is equal to r cubed. Now, if this said r squared, we would take the square root of both sides. For a cube, to undo that, you have something called the cubed root. And it's very similar. It looks like this. It has that little index value of a 3. And to type that into the calculator, you hit the control caret button. And that will allow you to type in an index value into that root. So it would be cubed root. You would put a 3 into that index, and then you'd put the number by copying it in to the underneath the radical sign. Okay, and then you would end up with that. We'll practice that in class, but just wanted to show you all of those steps while we're talking about it.
And then for the last one, we have a rectangular prism. And again, we were given the length and the width and the volume, but we need to find what the height is. So substituting all these into our general prisms formula, you need to make sure that it's the area of the base that we're putting in here. So make sure you put in 8 times 6 when you do this, and then you will multiply those together, divide by 48, and then get your height as 9.
So it's just working backwards, still using the same formulas. That's it for us. We hope you have a great day.